Just when you thought soils couldn't get more exciting, I'm back with soil part 2. This is 4.3, soil composition and properties. Okay, so our goal today is to describe the similarities and differences between the properties of different soil types. So to accomplish this goal, we will describe the characteristics of soil. We're going to explain the usage of the soil texture triangle and look at some of these applications. So let's start by describing our types of soil based on their soil particle sizes. So we're mostly going to focus on sand, silt, and clay, but we threw gravel in there as a good reference point. So we see that sand is much larger than both silt and clay, and this is going to impact how they interact with water, how they interact with nutrients. And let's see this. So we classify our soils based on the percentage of sand, silt, and clay that they have. To do this, we use the soil texture triangle. So the soil texture triangle allows us to figure out how to name our soils based upon the percent of the sand, the silt, and clay. So in class, we've taken the soil, we've shaken it up, and we're going to watch the layers stratify out. We can measure those, get a percentage, and then figure out what to call our soil. So in the very top part, we have soils that are mostly clay. We have soils that are mostly silt and soils that are mostly sand. How we use this is we start with sand. We know that this imaginary sample is 75% sand. So we go here, we find 75% and we draw a line. Then we find 10% silt. So the percent silt is over here. We go to the 10%, we draw a line and we see that those two cross right here. Then we find that our sample is 15% clay. So this is the side for percent clay. We read it 15%, we go straight across, and we find that all three of these lines intersect at a soil type called sandy loam. So loam is a soil that is much loved by gardeners. It's almost an even mix between sand and silt, and then has a little bit of clay. So it's supposed to be ideal for water holding and also for its permeability. So it holds water, but not too much. It's more like the Goldilocks soil. Not too much, not too little, just right. You'll see that as you get outside of just pure loam, we have, with a little bit more silt, we get silt loam, then we get clay loam, then we get sandy loam. And all of these have different properties based upon how you plan to use it. So let's look at one more example. So with a 10% sand, 83% silt, and a 7% clay soil. So we start with sand. We see that it's at 10%, so we draw our, I'll start with sand, sorry, sand. And we draw our line at 10% right here. Woo, go up there. Then we have 83% silt. So we find percent silt, roughly 83. Do a line here. And then we have 7% clay. So we go over here, percent clay. This is 0, there's 10, find 7, come across, and we get something that's 83% silt with a little bit of sand and clay is basically still silt. So I've mentioned water holding capacity. So water holding capacity is the total amount of water that your soil can hold. So this is going to vary by different soil types and how you mix them together. So adding different types of soil to the soil that you naturally have is called amending. So you're changing your soil. And water retention contributes to how productive your land is and how fertile your soils are. So we know that different soil types have different water holding capacity. Sand has the least and clay has the most, to a point where we can see that the sand is holding all the water here and it's going right through it. The silt, it passes in and moves down slowly, and then the clay, it basically sits on top. So you can change your water holding capacity by adding organic matter. So we can add cover crops. So this would be, instead of allowing the soil to be bare, we add a crop on top. You can use less tillage, so instead of digging in the ground and mixing up our soil, you can add clay. So we can increase our water holding capacity by adding more clay. or manure or compost. So you may have added compost to your own garden. So then we also have porosity, which is the amount of airspace in the soil. And this kind of runs the opposite of water holding capacity. Sand is the most porous, it has big gaps between it. Silt gets smaller, and clay is pretty hard packed together. So you can see plants tend to like something that has a bit more porosity to it because it's easier for their roots to move down through. And then we have permeability. This is how quickly the water flows through it. So this is going to be the opposite of water retention. So sand is the most permeable. It has the least amount of water retention, but the most amount of drainage because the water just goes right through it, again, because it's more porous. Clay has the least amount of permeability because those molecules are tightly packed together and therefore have a higher ability for water retention. So, as I mentioned previously, not all biomes have the same soil. You may think that an area like the rainforest, which is full of vegetation and full of rain, would have really great soils. However, they don't. They get so much rain that their soils tend to be a bit more acidic. And because they're more acidic, that changes the way the nutrients and the pH of their soil is. And with all of that fast growing plants, they don't have a lot of nutrients because the plants are growing so quickly because of that biome and that temperature that they suck up all the available nutrients. Then we see the deciduous forest, and we've got a nice humus mineral mixture right here, some great stratification. We've got that O horizon has that forest leaf litter, and that's what I showed you in the last PowerPoint, which leads to a really nice humus mineral mixture here. So let's compare this to some of the other soils. So next we also have the desert soil and the grassland soil. These two are like totally different. So the desert soil, we know it's hot and dry. There's not a lot of organic matter. Things don't decompose very quickly there because there's not enough moisture. So they basically have no O horizon. There's no decaying matter on top because it's so hot and so dry. So you see a lot of clay, and because there's a lot of clay, clay holds on to nutrients really well. So you get a lot of minerals like calcium and carbonate and soluble salts in the desert soils. Then we see the grassland soils. This is the heart of America's agriculture right here. They have really rich, slightly basic soils, really great humus for growing. And then at the bottom, they've got a base of clay with calcium compounds. So there's a couple different tests that we run. We test for pH, and soil pH, again, is related to the climate. So where we are, we tend to have soils that range more in this slightly acidic range here. If you go further north up to Maine, we see really acidic soils, and then very basic soils out here and in the west. We also test for 3 common macronutrients. These are nitrogen, phosphate, and potassium, but you'll also see potassium written as potash. And we also look for the amount of salt content in the soil. An important property of soil we have not fully discussed, we've alluded to, is our biological properties of soil. And this is all those microbes. So it's hard to read here, but there's bacteria, there's fungi, there's all different kinds of mites and worms and protozoas, all active in our soil. And it's said that a teaspoon of soil contains more living organisms than there are people in the world. So that's pretty impressive. And they're really what gives soil its importance here on Earth. So, to summarize, we've attempted to describe similarities and differences between properties of different soil types. Today we learned that the physical properties of soil we can check their texture, so the amount of sand, silt, and clay, how permeable they are, how porous they are, and how much water they can hold. Again, if you have a field that has corn in it and you don't want to have a lot of clay because that clay is going to cause a lot of water to build up on the surface, you want some permeability and some porosity. On the flip side, if you're a landfill, you don't want all of your landfill stuff getting out. So you're going to want to have a layer of clay underneath it to keep that trapped in. We learned about the biological properties of soil, which is the amount of soil microbes, and then the chemical properties of soil, which are the pH, the nitrogen, phosphorus, and potassium, and the salt content.